Hey everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 4.3. This section is going to be important because it does tie into the next section, and it is probably one of the more essential parts of chapter 4. So right here, if you take a look at the following, we have a situation where we have two specific types of properties that we know. Okay, and this should be pretty straightforward, right? Remember we talked about this. If you have a base a raised to the log with the same base, it just kind of cancels out and you're left with m. And then same thing if I have log a base of a to another a, right? It kind of cancels out as well. And that's where we get r and m respectively. Okay, for the following. Okay, so for the following here. Okay. Remember, let's just talk about this here. Remember a couple things for the following. Okay, so remember if you just have natural log, you always have base e, so that's why this one cancels out and you're left with -4. This one cancels out, you're left with 7. Okay, now remember this also as well, that when you are looking at the following here, okay, laws of exponents, right? So this one's a trickier one, but I can break this down as 5 log of 5, 6 times log of 5, 7. Okay? Sorry, with a 5 on the bottom. Okay? So let's talk about this. The first part here will cancel out, and you're left with 6. The second one will cancel out, and you're left with 7, and that becomes 42. Okay, now some of you guys are probably wondering, why did I get this situation? Okay, so if you recall, let me kind of scroll down. Remember, you have this rule called laws of exponents. Okay, so laws of exponents, you have the following. If I have x to the a times x to the b, I can add my exponents together. So that's what we did here, only we went backwards. Okay? So if I multiply things with the same base, that's why I add the log base 5, 6 plus log base 5, 7. Okay, and you can go backwards and forwards with that. Remember also with laws of exponents, if I have x to the a divided by x to the b, this will be x to the a minus b. Okay? And then also, if I have a power to a power, I will multiply them out. For the following. So why am I showing this to you? Okay? So remember, exponents and logarithms, right, they're inverses of each other. So they're generally kind of backwards, but at the same time, they also have properties are very similar. So logarithms also have their own laws as well. Okay, so right, we had laws of exponents in terms of multiplication, division, and to the powers. Okay, and right, this is called product. This is called quotient. And this is called power. Now here's a thing. Law of logarithms have very similar ones. So let's take a look at this one. So we have log of a product. So if I have a log and I have two things multiply to each other, I add them, which is very similar to laws of exponents, right? If I multiply, I add my exponents. If I divide my logs for the exponents, they subtract. Same thing for laws of exponents as well, for quotients. And if I have a power to power, I'll multiply. Now this one's a little tricky. It actually comes down, and then you can multiply. Hence, that's why we have the r in front as well. Okay? So take a look at this. Make sure you know these three rules really well. Okay? But again, if you kind of get stuck, think about laws of exponents, right? If you multiply two bases, you add your exponents. If you divide by the same bases, you subtract. And if you raise a power to power, you multiply. So the same thing kind of applies to logs, okay? And remember, this assumes that they have the same base, right? You can't do them with different bases, okay? So essentially what 4.3 is simply the fact that you will be asked to essentially take a log and you can split into pieces, or you get a bunch of pieces and you put them together, okay? So let's take a look at this. Okay, let me give you some examples. So these here are examples where they give you one logarithm and they ask you to write it as a sum or difference or log of logs. And then they also ask you to write powers as factors. Okay? So let me repeat that again. So you have one log, and then they'll ask you to break it up into addition or subtraction and express the powers as factors. Okay? So if I take a log of 5 of 25x, okay, the thing is I realize is 25 is multiplied by x, and if I look back up, right, if I'm multiplying, that means I add them. So this is what it's going to look like. I'm adding them, and I split them separately because I multiplied initially, right? So multiplication becomes a sum of two logs, okay? Now you will be asked to simplify sometimes, okay? So this one, the first one here, I need to simplify this. Now let's remember how we simplify this, okay? Let's say I have x is equal to log of 525, right? What will that value be? Okay, right? That means I swap it. If you remember, right, I swap my x and I swap my 25s. I'm saying 5 to the x is equal to 25. What will that be? That means x has to equal to 2. So this simplifies into the following, which is 2 plus log base 5 of x. Okay, that's my final answer. Okay. Let's look at number 2 here. Notice I'm dividing, so that means I'm using quotient rule. So this becomes log base 5 of x minus log base 5 of 125. So the one that's in the bottom, you're going to subtract. Second. Okay. If I have two numbers, I also want to simplify as well. So I will say x is equal to log base 5 of 125. So remember, to go to exponential form, you're going to swap. And what would 5 raised by x? That will give me 125. That will be x is equal to 3. Okay. Now let's take a look at number 3 here. So what I'm going to do is, remember, if I have a power, I can write it as a factor. So notice I have a z raised to a third. That's a power rule. So that means if I want to go backwards, I'm going to take this 3 and I'm going to move it to the front. So it's going to look like this. 3 times log base 2 times z. Okay. So we did some of the easier parts. So let's take a look at this right here. So what will happen, for example, if we have multiple situations happening, okay? So some of these can get pretty tricky, okay? So for example, let's just do, let's take a look at example number 6 here, okay? So you will definitely run into situations where you'll have multiple problems happening at once. So just be careful. You want to do this slowly, step by step, okay? Now, think of order of operations, right? What is going to be the thing that you would do, like, that separates, right? You should realize there's a division. So you can split this up as log of x times the quantity x plus 2 minus log of x plus 3 squared, right? Because I'm dividing x times x plus 2 over x plus 3 squared, okay? For the following, okay? So, and that ends up being subtracting. So then do a little bit at a time. Yeah, so when you have a situation that's very complicated, again, slow down, do one small step at a time. So I notice x times x plus 2, this is going to be log of x plus log of x plus 2. Now I want to remind you guys, okay, be very careful. So notice I put parentheses x plus 2. The reason why is if I write it like this, notice this is very different, right? Look at the difference between without parentheses and with parentheses. So if I do without parentheses, notice the following here where I just have a 2 by itself, right? But this one, the second one, right, x plus 2 are kind of together, okay? So you need to be really careful about that there, okay? And then I'll bring my log of x plus 3 squared. So the only thing I realized that I need to do is I noticed that I have x plus 3 quantity square. So the 2 is going to move down and everything else stays the same. But then the last part is going to be the following. It'll be minus 2 times log of x plus 3. Okay. We're following. And that's pretty much it. Okay. So just make sure you slow down and do a little bit at a time. Okay. We're following here. Okay. Now let's take a look at one more example. I'm going to show you number 7 here. So number 7, okay? This one is a tricky one. So let's talk about this right here. Okay? Now, which one will we do first, okay? I will actually not divide this time. I will not use quotient rule. Some of you guys are like, why would I use quotient rule? Or sorry, why would I not do quotient rule first? The reason is, if you notice, the whole thing is being raised to the 1/3. So I actually have to FOIL that part out, or I have to kind of bring that part down. So it's going to look like this. 1/3 times natural log of x squared minus x minus 2 all over x plus 4 squared. Okay? Okay? Then I can break it apart, right? You see that I cannot do subtracting because they're both raised to 1/3. I have to almost peel off the 1/3, and then I can split them up. Then I can split my fraction up. So the 1/3, I'm going to break my x squared minus x minus 2, my x plus 4 squared by subtracting. Now the thing you need to be careful about is you have to realize you're actually multiplying everything by 1/3, okay? So I'm going to be like natural log of x squared minus x minus 2. Again, make sure you put that in parentheses. And then minus parentheses natural log of x plus 4 squared. Okay? You can distribute the 1/3 if you want, but I'm just kind of leaving it out, just realizing I'm multiplying everything by 1/3 at the end. Okay? The next thing I want to realize is, now this is something, the reason why I'm doing this problem is because it's definitely one of the trickier problems. So what I'm going to do is I'm going to factor this for the following. And this will be natural log, and I have to factor this as x minus 2 times the quantity x plus 1. Okay. Why would I do this? Okay, because then I realize I'm multiplying, so I have to split this one up once again. So this is 1/3 natural log of x minus 2 plus natural log of x plus 1 minus natural log of x plus 4 quantity square. Now, let's see what's the last steps I'm going to do. Notice I have a square on top. I have to bring that down, okay, for following. So it's going to look like this. 1/3 natural log of x minus 2 plus natural log of x plus 1 minus 2 natural log of x plus 4. And then the last thing I'm going to do is I'm going to distribute my 1/3. And this is 1/3 natural log x minus 2 plus 1/3 natural log of x plus 1 minus 2/3 natural log of x plus 4. Okay. So that's it, and that's my final answer right there. Okay. Yeah, so this one's definitely a tricky one. You have to realize you need a factor, okay? And then look at you want to kind of look like, the way that you want to think about it is you want to look outside the in. So it's almost like you're almost peeling like an outside layer. So if you look at 7, right, I don't do the quotient rule because the 1/3's out first. Versus number 6, if I look back up, right, I can divide it because I don't have anything outside for the following. Okay. Now, for number 8, let me show this to you right here. Okay, I'm not going to do this for you, but just remember, trick thing is, notice if I have cube root, I should realize it's the same thing as x squared plus 1 raised to the 1/3 over x squared minus 1. Okay. So be mindful about that, okay, for the following here. Okay. And then one last thing too, with these problems, notice they say x is greater than 0 or x is greater than 2. The reason why is if it's less than those numbers, you actually will not, it will actually be outside the domain, so the natural log won't exist. So the problem essentially is they're just restricting your domain so that you're saying this will always work all the time. Okay, but don't worry too much about that. It's just a characteristic to making sure that your solution works all the time. Okay. So the second part of section 4.3 deals with the following. You're essentially going to go backwards, okay? So they will give you multiple logs, and then you have to write it as a single log. And I forgot to write this down, but you want to write your factors as powers. Okay. Sometimes just your coefficients. Okay. Okay. So sometimes the order is a little confusing, okay? In terms of, should we like raise them up? Should we multiply? Should we divide? When should we do this, okay? So here's a trick to kind of help you remember. If you scroll all the way back up to your powers, okay? So it says log of a m plus log a n, you would multiply them, okay? And then log base a m minus log a base a n, you would when you subtract, you'll divide. Now, if you notice with both of those rules, those only work if you don't have a number out in front. So if I scroll back here to number 1, notice the following. I have 3 log base 5u plus log base 5v. Okay? So they have the same base, which is good. They both have base 5. So remember this as well. If they do not have the same base, you cannot combine them together, right? You cannot multiply. You cannot do quotient rule. You cannot do product rule. Okay? But the issue at hand is, notice I have 3 and 4 in front. So because I have a 3 in front of my first log and a 4 in front of my second log, I actually can't combine them together. But what can I do? I realize I can take my coefficients and write them as powers. I move them back up. So it's going to look like this. Log base 5u cube plus log base 5v to the 4th. Now, because I'm adding and they have the same base and I don't have a number in front, I can multiply them together. So this ends up being log base 5 u cubed times v to the 4th, okay? And then you can put parentheses. It's not necessary, but just to show that they're 1 unit for the following here. Okay. 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 So let's look at example number 4 here, okay? 4 is kind of similar, although it's a little bit trickier, okay? And one thing, once again, that you'll see is you'll have a lot of pieces where you have to do multiple rules, okay? So let's take a look at number 4. So some of you guys may notice that there's a subtraction, and some of you guys are like, well, we should divide. Now remember, we can't do division if I have a number in front, so I have to move it up first. So it's going to look like this. Log base 4 x squared minus 1 minus log base 4 x plus 1, and I'll raise it to the 5th. Okay? So now, because I can subtract, and now I don't have a number in front, now I can divide like the following. So I do log base 4, and it'll be x squared minus 1 all over x plus 1 to the 5th. Okay, now one of the things we have to be mindful is see if we can factor anything. Okay, and this will happen quite a bit when you're combining. Okay, you want to simplify a lot of times as you go along. So notice x squared minus 1 factors into x plus 1, x minus 1. And I notice I have an x plus 1 on top and an x plus 1 to the 5th. That means that x plus 1 being multiplied 5 times by itself. So that becomes 4th. So it ends up looking like this. And that is my final answer right here. Okay. Let's look at 2 more examples. Yeah, so let's look at something like number 8, okay? It's definitely one of the trickier ones for sure. So I have 21 times log base 3 cubed x plus log base 3 9x squared minus log base 3 to 9, okay? So here's the thing. Because it's in radical form, let's talk about what cube root of x is. Remember, this is the same thing as 3. Instead of cube root of x, I can say this is x to the 1/3. Okay. Now, I have multiple things happening at the same time. Okay. So, the first thing is, if you notice, I cannot combine these, right? Because I have a number in front. So I need to move it up on top. So this is log base 3 x to the 1/3 raised to the 21st plus log base 3 9x squared minus log base 3 9. Okay? So if I have a power to a power, I'm going to multiply. So this is log base 3 x to the 7th. Okay, now let's talk about this. What do I do if I have multiple addition and subtraction? One of the things is, remember when you do PEMDAS or when you do order of operations and you have addition and subtraction, right? What do? You read left to right. So the same thing applies with logarithms. So if I'm adding and subtracting, notice the following here, right? I would add first because addition's first and then subtraction is last, right? If I'm reading from left to right. So I have x to the 7th times 9x squared. Okay. Now, remember, you want to simplify as you go along. So x to the 7th times 9x squared is essentially 9x to the 9th. If I divide, now I can divide. So this is log base 3, 9x to the 9th divided by 9. And then my final answer is log base 3, x to the 9th. And that will be my final answer right here. Let's look at one more example. So let's do number 7. Let's look at one more. So I would do this first subtraction and the second subtraction. I do realize I have a 3 in front, so I need to move up. So it looks like this. Oh, and then I also notice my 2, I need to move up. Yeah, so when you're putting things together, always the first thing you always want to do is take your numbers in front and raise them as a power. Okay, so we're going to divide this one first. So it's going to look like this. Oops, sorry. Does everyone see that? So I combined these two as 1, but I still have a minus log of 5x. Okay, so let's think about this, right? I'm dividing. If I do this divided by, if I do this entire thing divided by x, the x is going to jump to the bottom. Okay, think about you flip it upside down. So it'll be on the bottom, so it'll look like this. Okay, so that is my final answer. Okay. Okay, so let's talk about one last thing here. What happens if we have a logarithm which we don't have a base 10 or e? And this is important because remember we talked about this before. In my calculator, right, if I look at my calculator, I only have natural log, which is base e, or log, which is base 10. Okay? But if I want to do base 5 or base 7, right, what do I do with that? I can't really use my calculator. So this is where you can use this formula, which is called change of base formula. Okay? And essentially it is the following. If you have a base and then you have this number or this item out in front, the item out in front will go on top and then the base below will be on the bottom. And you either do logs or you do natural logs. Okay, so let me give you an example. So if I have log of 21 base 3, what I'm going to do is I can write this as log of 21 over log of 3. Or I can write this as natural log of 21 over natural log of 3. So what I'm going to do. So I'm going to do log of 21 divided by log of 3. So notice my answer is going to be 2.77. If I do natural log of 21 and natural log over natural log of 3, I'm also going to get the same thing. Okay? So either one will work. I get approximately 2.77 for both of them here. Okay? And let me show you one more. So if I have log base 1/3 over 71 of 71, I do the same thing. I can write it as log of 71 over log of 1/3, right? Or I can write it as natural log of 71 over natural log of 1/3. Okay, let me put these both in the calculator. So as you can see, we end up with the same number. So I have negative 3.88 and negative 3.88. Okay. Yeah, and so one last thing you can do too is, let me show you this, is if you want to graph, right? So notice if I have log base 4x, I can't graph that, but what I can do is I can do log of x divided by log of 4, and that would actually show me my graph right here. Okay, so I can use that to help me out. Okay, so that's it for 4.3. Please practice this, okay? The main takeaway is make sure you know your 3 properties of logs, and then make sure you want to do the more complicated ones. You want to slow down, do a little bit step by step. If you have questions, let me know. But other than that, I will see you guys later. We'll start with 4.4.